Good morning, everyone. This is one more session with respect to Linux system programming. In this session, as all of you know that we started working on IPCs, interprocess communication. In today's session also, we need to discuss the concept of IPC. So before starting with the today's session, if my voice is clear, able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. In a last session, we started thinking about two concepts. One is redirection. Will you agree? In a last session, we are trying to understand one concept called redirection. That is output redirection, input redirection. Now, can you tell me, in output redirection, what is the steps we need to do? In output redirection, what is the steps we need to do? We need to close the file descriptor 1 and we need to open the file. Listen, now after these two steps, whenever you use a printf, it will not print on the screen, it will print it into the file. Will you agree? After these two steps, whenever we use a printf, it will not print on the screen, it will print into the file. Yes or no? Please reply it. In an input redirection, we need to close 0, open a file where the inputs are there. So then scanf will scan the data from the file. In an input redirection, we need to close the file descriptor 0. After that, open a file using the open system call in the read mode. So scanf will not scan the data from the file, from the keyboard. It will scan the data from the file. Will you agree? Now can you tell me, after closing the 0, when you open a file, so what is the file descriptor is assigned to this file, whatever you opened? When you, after closing the 0, whenever you open a file immediately, what is the file descriptor is assigned to that file? Can I say, for that file, the file descriptor is assigned as a, 0. After this discussion, will you agree, we started thinking about one more important discussion, that is IPC, inter-process communication. How the two processes can communicate between each other, how the multiple processes can communicate between each other, that we started thinking. As all of you know that in a RAM, there are multiple processes are there. As all of you know that one process cannot access another process memory. If one process is trying to access another process memory, we will get a segmentation fault error. If one process is trying to access another process memory, we will get segmentation fault error. If suppose one process wants to communicate with another process, they need to take the help of kernel supported mechanisms, kernel supported features, kernel supported methods, that is called IPC mechanism. Now the question arises, why one process need to communicate with another process? I told you processes are categorized into two things. One is independent process and another one is cooperative processes. Independent process means that process doesn't require any other process help to perform the task, and other process also doesn't affect this process execution. Independent. Another is cooperative process. Cooperative processes means, so the processes, they need to, one process execution is depends upon another process execution. Now can you tell me what is the benefit of cooperative processes? What is the benefit of cooperative processes? I told you, whenever you want to perform any task, the task is a bigger task. We need to divide it into small tasks. So there are several reasons why the cooperative environment is required. Now can you tell me, nowadays we are in a world, are we independent or we need to, like, is it a cooperative processes? Can I say our process execution is depends upon another, data should be exchanged? Listen, nowadays the communication plays a major role. Nowadays the dependency, like the communication requires a major role. So the benefit of cooperative processes is information sharing, computational speed up, modularity, and convenience. Again, the benefit of cooperative processes is information sharing, computational speed up, modularity, and what? Convenience. So if one process wants to communicate with another processes, our kernel is supporting some methods, that is IPC methods. In a last session, we started thinking about one IPC mechanism, that is called in the last session we started thinking about one of the IPC mechanism, that is called pipe. Now can you tell me how to create a pipe? When you create a pipe, what happens inside? Can you tell me how to create a pipe? When you create a pipe, what happens inside? We need to create a pipe using pipe system call. When we create a pipe, how many file descriptors you will get? When you create a pipe, how many file descriptors you will get? Can I say 2 file descriptors? Now one thing I need to discuss here, suppose this is one process. In this process, I created a pipe. Listen the statement very carefully. Suppose this is one process. Suppose the process Y. In this process, I created a pipe. Now you will get a 2 file descriptors, right? Can you tell me, for this process already how many file descriptors are there? For this process already how many file descriptors are there? Already, before creating the pipe, 3. 0, std in, 1 std out, 2 std error. Apart from these three, two more you will get when you create a pipe. Apart from these three, two more you will get when you create a pipe. What are those? 3 and 4. 3 p of 0, 4 p of 1. 0 for lower file descriptor is useful for reading. Higher file descriptor is useful for writing. Will you agree? All of you accept this point, type 2 in the chat box. A process is already having a 3 file descriptors, 0, 1, 2. After that, whenever a process is creating the pipe, 2 more file descriptors you will get it, 3 and 4. So now total how many file descriptors this process Y is having? Total how many file descriptors this process Y is having? Can I say 5? After this, using the fork system call, this process is creating the duplicate process, child process. Try to recollect yesterday's program. After that, that process Y is creating a duplicate process called Y plus 1. Process Y is creating the duplicate process called Y plus 1. Now what happens is, all these file descriptors, whatever the parent is having, all these are gets copied to the child. Try to understand. When parent is created a pipe, after creating the pipe, if the parent is creating the child process no need to do any explicitly create the pipe. Already parent created pipe, child will get it. So all those file descriptors are inherited to the child process. All those file descriptors are inherited to the child process. Any doubt in this point? Any doubt in this point? If no doubt, type N in the chat box. If no doubt, type N in the chat box. So, what is the condition? What is the rule in this IPC mechanism is, parent before creating the child only, parent before creating the child only, before creating the child, it need to create a pipe. Try to understand this statement. Parent before creating the child process, it need to create a pipe. Any doubt in this? So that all the parent file descriptors child gets inherited, so that all the parent file descriptors child gets inherited. This is one thing. Second thing, in the last session, we discussed some methods, right? We discussed some mechanisms where parent is scanning the data from the keyboard and putting into the pipe. Which end it is putting? Parent putting into pipe right end. And whereas child reading from the read end, and printing on the screen. This is the first task in the last session, we discussed it. Will you agree? Parent writing the data into the pipe after scanning the data from the keyboard, writing the data into the pipe, and child is reading from the pipe. I told you very important property. Read system call will block if the pipe is empty. Read system call will block if the pipe is empty. Will you accept this point? Similarly, write system call also will block when the pipe is full. Similarly, write system call also blocks when the pipe is full. So after this task successful done, we implemented one more task. After that task successfully completed, we implemented one more task. In that task, parent need to scan the data from the keyboard, put it into the pipe right end, put it into the pipe right end. Child need to read. After read, child need to convert into the string. It need to convert into the string. It need to convert into uppercase. After that, it need to write. After that, it need to write. Now, whereas parent, after scanning, after writing into the pipe, it need to read from the pipe the converted data. Parent reading from the pipe the converted data. But what is the problem in this? Can you tell me what is the problem we observed in this scenario? What is the problem we observed in this scenario? Can I say in some particular execution, sometimes after writing, immediately parent is reading. Will you agree? After writing, parent is reading immediately. So parent is not getting converted data. Will you agree? So parent is not getting converted data. Listen, parent is not getting converted data. That is technically called loop back. I don't know you know it or not. In a serial communication in your microcontroller, if RX pin and TX pin when you short it, what happens? Whatever you are transferring, you're going to receive there itself. Whatever you are transferring, you're going to receive there itself. That is called as a loop back. Now here also the same loop back happens sometimes, not in all the cases. Yesterday, that's what in the last session, that's what we observed it. Now, what is the solution I told you? The solution I told you, we need to use two different pipes. The solution I told you, we need to use two different pipes. The solution I told you, we need to read two different pipes. Observe this diagram. Observe this diagram. In this diagram, this is the right end, this is the read end, this is the right end, this is the read end, two pipes. What is the parent process is doing? What is the parent process is doing? Parent process is writing into first pipe, child is reading from the first pipe, child is writing into the second pipe, parent is reading from the second pipe. So this is a duplex. Duplex communication. Both sides data transferring, receiving is happening. Parent can write, can read. Child can read, can write. Is that point is clear? This is the duplex, and one more. Today, our first task is write a program for finding the size of the pipe. Write a program for finding the size of pipe. So tell me, what is the procedure I need to do for finding the size of the pipe? What is the procedure we need to do for finding the size of the pipe? I told you, keep on write character by character. Don't read it. At one stage, pipe will full. At one stage, pipe will full. Now observe, VI 2709 underscore 1 dot C. Well, if you observe this, header dot h, void main, now observe, let's create a pipe, int p of 2, pipe of p. I need to take one counter, int c is equals to 0. After creating the pipe, what we need to do? After creating the pipe, what we need to do? We need to keep on writing the data into the pipe. While write, what is the first argument for the write system call? What is the first argument? P of 1. Second argument is ampersand of ch. Third argument is 1 not equals to minus 1. I hope all of you might have remembered. While system call will return minus 1, write system call upon failure it will return minus 1. Count is incremented. Printf c is equals to %d slash n comma c. Now tell me, what is the failure condition I written so that my program will execute, will come out from the while loop? What is the failure condition I written? When write will fail, when write fails, it should come out. When write system call fails, will you agree it should come out? All of you are observing line number 9. When write system call fails, it should come out. Let's compile the code. Let's compile the code. Let's run the code. So these are number of bytes. We are not reading. We are keep on writing. Now tell me what happens? Write is not failing here. Write is blocking. All of you are observing command from not came by statement is not printed. Write is not failing here. Write is blocking. Write system call is not failing here. Write system call is blocking. What is the size of the pipe in my kernel version? 65536 bytes. 65536 bytes. Not 2 power 32, it is a 2 power 16. F1. It's not a 2 power 32. 2 power 32 means it is a 4G. 65536 bytes. My question is, why this by statement is not printed? My question is why this by statement is not printed? Can I say this write system call is not failing here? Write system call is blocking. When the pipe is full, write will block. Will you agree? Now, if you don't want to block the write system call, you create a pipe using pipe 2. If you don't want to make the pipe system call to block, you don't want to make write system call to block, use a pipe 2 and set a flag called O underscore non-block. And set a flag called O underscore non-block. That's some header file we need to include, I think. That is the reason it is giving us a warning. Let's see. After completion, will it block or will it fail? We'll see. See, now you tell me. After that, write is blocking or write is failing? After that, write is blocking or write is failing? Now, will you agree? Will you agree? Write is failing. So, you can create a pipe using the two functions. You can create one thing I need to ask you, where the pipe is created? In a RAM or in a hard disk? First tell me where the pipe is created, in a RAM or in a hard disk? Answer is in a RAM. In a hard disk, nothing. When you type ls, nothing it is displayed. When you type ls, nothing will be displayed. B9J1, the pipe is created in the RAM. In a RAM, which space? In a kernel space or user space? Pipe is created in the RAM, okay. In a RAM, in which space it is created? In a kernel space or in a user space? Answer is in a kernel space. Processes are in a user space. They can communicate from the kernel. Processes are in a they can communicate in a kernel, through kernel. Is that is clear? Now, what is the size of the pipe in this my laptop kernel version? 65536 bytes. Now, some important points about the pipe, we need to discuss it. Some important points about the pipe we need to discuss it. Till now, whatever it is discussed, if you feel yes sir, it is clear, type C. Now observe, here two pipes are not created. Don't assume that here two pipes are not created. It will only one pipe. This is a function. Pipe 2 is one more system call. Pipe 2 is one more system call. Not the meaning that two pipes are created here. Got the point? The student who asked it, B9K2. Here two pipes are not created, only one pipe, but system call is pipe 2. Here we used pipe system. Okay. Now let's observe some important key points about the pipe. 7 means, already I told you, 7 means man page 7. Will you agree it is overview? Man page 7. Will you agree it is overview? Observe. Observe this point. if a process attempts to read from empty pipe, then read will block until the data is available. This already you know. If a process attempts to write to the full pipe, then write will block until the sufficient data has been read from the pipe to allow the write to complete. To allow the write to complete. And there is one function fcntl is there. We can set the flag. Instead of this, you can create pipe using the pipe 2. Instead of this, you can create a pipe using the pipe 2. And one more important point about this IPC is this communication channel provided by pipe is a byte streaming. There is no concept of message boundaries. Suppose if you put hello and if you put hi, so hello and hi is not treated as a separate. It is treated as only one. Hello when you write it, hi when you write it. When you read at a time, you can read both at a time. So there is no message boundaries. It is not. It is a byte streaming. Is that point is clear? For boundary purpose, you can put /0. For putting a boundary, you can put a /0. For putting the boundaries, you can put a /0 there. So the communication channel provided by the pipe is a byte streaming. When you set this flag, good question. Observe. Here, when you use O_ non-block, both read end and write end becomes a non-block. Again, when you use O_ non-block, both read and write ends becomes a non-block. When you use O_ non-block, both read and write both ends becomes a non-block. Now, if you want to non-block only write end, D8 F1, if you want to non-block only write end, then what you need to do is you need to use FCNTL. Then you need to use FCNTL. Once we started with the FCNTL, we'll discuss it. Again, very good question. When you create a pipe using the pipe system call, when we use O_ non-block pipe 2 system call, when we use O_ non-block, both read and write end becomes a non-block. Both read end and write end becomes a non-block. If your requirement is only one end to be non-blocked, which end? Only one end to be non-blocked, right end. So then, instead of creating the pipe using the pipe system call, you can create a pipe using the pipe system call. After that, you can use FCNTL function, F_setfl and O_ non-block. If you want, I'll show you that. Which end you want to make as a non-block? Which end you want to make it as a non-block? FCNTL right end F_setfl O_ non-block. I think we'll see will it works or not. Let's see. Now write will block or write will block or not. See, now tell me, Yamai created, all of you are observing here, Yamai created a pipe now using which system call? I created a pipe using which system call? Observe the line number 7. I created a pipe using which system called pipe. After that, which end of the pipe I'm making as a non-block here? After that, which end of the pipe I'm making as a non-block here? Can I say right end? But read end still is a block. If pipe is empty, in this case, read end behaves still block. But if you create a pipe using a pipe 2 and if you set this flag, if you create a pipe using the pipe 2 and if you set this flag, can I say both ends behaves as a non-block? Will you agree? Both ends behaves as a non-block. Now tell me, I don't want to print count continuously. I want to print the count at a time. So what should I do? I don't want to print the count continuously. I want to print the count in a single shot. See, 65536. But if I put open and close brackets, what happens here? Can you tell me, if I put open and close brackets, what happens here? In this, if I put open and close brackets, can I say the printf will print continuously? Printf will print continuously. Is this clear? Is this clear? Okay. One more important point I need to show you here. One more important property about the pipe. Observe. If all file descriptors referring to the right end of the pipe have been closed, then attempt to read from the pipe will see end of file. Read will return 0. All of you copy up to this. From this to this, all of you copy. Take a time and copy. From this to this. If all file descriptors referring to the right end of the pipe have been closed, if all file descriptors referring to the right end of the pipe have been closed, if all file descriptors referring to the right end of the pipe have been closed, then an attempt to read from the read end of the pipe will see end of file. So it will return 0. I don't know, you remembered or not, read system call, I don't know, you remembered or not, read system call, upon failure it will return -1. Upon success it will return number of bytes read. Upon file is ended it will return 0. Very important point. Try to listen the statement very carefully. Read system call, upon failure it returns -1. Upon success it returns, upon failure it returns -1. Upon success it returns number of bytes fetched from the file, from the pipe, from the file or pipe, whatever it is. Upon success. Upon file is ended, it will return 0. Upon file is ended, it will return 0. All of you copied this. If all file descriptors referring to the right end of the pipe is closed, if you close the right end, if you're trying to read from the read end, read will see end of file, it will return 0 to us. Now the second point, there is one signal called the sig pipe signal. If all file descriptors referring to the read end of the pipe have been closed, then write will cause sig pipe signal. Again, if all file descriptors referring to the read end is closed, then you are trying to write from the right end. A process receives one signal. Process receives one signal that is called a sig pipe signal is generated. Again, now can you tell me? I'll write the statement here. If all file descriptors referring to right end is closed, and attempt to read from read end, read will see EOF end of file. It returns 0. It returns 0. Second point, if all file descriptors referring to read end is closed, if any process attempt to write, that process receives SIG PIPE sig pipe signal. If all file descriptors referring to read end is closed, if all file descriptors referring to read end is closed, if you're trying to write from the right end, U means any process. If any process is trying to write from the right end, then that process receives sig pipe signal. Can you tell me what will be the default action of the sig pipe signal? Can you tell me what will be the default action of sig pipe signal? What is the default action of sig pipe signal? Process is going to terminate. Default action of sig pipe signal is process is going to terminate. Process is going to terminate. Is it clear? Just give me 1 minute of time. Just give me 1 minute of time. I will be back. Please give me 1 minute of time. I'm going to mute myself. Any doubt in this particular point? So if a process is reading where right end is closed, if a process is reading where all the right ends are closed, then read will see end of file, it will return 0. If process is writing where read end is closed, what is the meaning of all file descriptors? Here one point you need to observe. What is the meaning of all file descriptors? What is the meaning of all file descriptors? Means how many processes are using this pipe, means how many processes using this pipe, in all those processes it should be closed. I'll show you one example, it will be more clear. Suppose this is the parent and this is the child 1, this is the child 2. So parent, 2 childs. So here 0, 1, 2, 3, 4. Here also 0, 1, 2, 3, 4. Here also 0, 1, 2, 3, 4. Now 0, 3 means which end? When you create a pipe, 3 means read end. 4 means write end. Now here also read end, write end. Is it? 3 means read end, 4 means write end. Is it? Yes or no? Please reply it. Okay. Now here also 3 read end, 4 write end. Suppose here also read end is closed, here also read end is closed, here also read end is closed. Suppose here also read end is closed, here also read end is closed. How to close read end? Close system call, close P of 0. Using the close system call, you can close it. Using the close system call, you need to close it. Okay. So now in every process, this is the first process, second process, third process. We'll agree in all the processes, a read end is closed. Will you agree? In all the processes, read end is closed. In all the processes, read end is closed. So if suppose this process is trying to write into the pipe, then if suppose that process is trying to write into the pipe, then if suppose that process is trying to write into the pipe, then if suppose that process is this process C2 is trying to write into the pipe, then that process receives sig pipe signal. Then that process receives a sig pipe signal. All of you are getting the point? That process receives a sig pipe signal, process gets terminated. Definitely default action is sig pipe signal is, default action of sig pipe signal is process gets terminated. Default signal, default action of sig pipe signal is process gets terminated. Got the point? Suppose this process is not closed this read end. Suppose this process is not closed this read end. Now you tell me in remaining processes read end is closed, but this process is not closed the read end. When this process writes, will it receive the SIG pipe signal or not? Suppose one process is not close the read end, another process is trying to write it. Will it receive the SIG pipe signal or not? Answer is no. Answer is no. That's what, if all file descriptors referring to the read end is closed, that's what the meaning is. If all file descriptors referring to the read end is closed, if all file descriptors referring to the read end is closed, if you are trying to write from the right end, then the process receives a SIG pipe signal. Otherwise, if one process is not closed the read end, so then SIG pipe signal the process will not receive. Then SIG pipe signal the process will not receive. Any doubt in this? Any doubt in this particular point? Now, can you tell me, can you implement one scenario? Can you implement one situation where parent, suppose parent is a server. Suppose parent is a server. Parent is scanning a roll number from the user. Okay, parent is scanning the roll number from the user and send it to child. Parent is scanning the roll number from the user and send it to the child. Now what the child need to do is, with this roll number in the file, the data is there or not, you need to check. Roll number, name, marks, roll number, name, marks, roll number, name, marks, roll number, name, marks. So what the parent need to do? Parent, just a minute, it is not a server. Parent need to scan a roll number from the user. After scanning the roll number, it need to send the roll number to the child. What the child need to do? What the child need to do? Child need to check, search with that roll number, the data is there in the file or not, it need to check. If with that roll number the data is there, it need to send it to the parent. The roll structure, total structure you need to send it. Roll number, name and marks. If not there, you need to send a 0. If not there, you need to send a 0. Now can you tell me here who is acting as a server? Who is providing the service of searching? Who is acting as a server? Who is providing the service as a searching? Can I say child? Or can I say here child as a server, parent as a client? Client need a service. Server provides the service. Will you agree? Client need a service. Server provides the service. Now here, first, from the parent to the child, what you need to send? From the parent to the child, what you need to send? You need to send integer. Child, what it need to send? Child, what it need to send? Child, what it need to send? A structure. In that structure, first roll number, next name, next marks. If suppose in a child, in a server, the roll number is not present, it need to send a structure. In the structure, first roll number will be, in the structure, first roll number will be 0. So that parent need to read the structure, and if in the structure roll number is 0, parent need to display not found. Otherwise, it need to display roll number, name, and marks. Otherwise, it need to display roll number, name, and marks. Otherwise, it need to display a roll number, name, and marks. All of you are getting the point? All of you are getting the point? So, initially, parent need to scan a roll number from the user, send it to the child using the pipe. Only roll number it need to send. Child is acting as a server. With that roll number, any data is there or not, child need to search in their database file. If is there, entire structure, roll number, name, and marks, it need to send it. If not there, in the structure, in the place of roll number, it need to put a 0, remaining no need to fill, it need to send it to the parent. What the parent need to do? Can you tell me what the parent need to do? Read the structure. What the parent need to do? Read the structure. And in the structure, if the roll number is 0, so then in that structure roll number is 0, then parent need to confirm. In that structure, if roll number is 0, then parent need to confirm. In that structure, if roll number is 0, then the parent need to confirm data is not there. If non-zero, it need to print that roll number, name, and marks. It need to print that roll number, name, and marks. Need to print that roll number, name, and marks. Any doubt in this specification? Any doubt in this specification? Now here, the main task, we need to write it in the child code. Will you agree? I hope all of you know how to read a structure from the file. Now, try to understand what is the disadvantage of this IPC mechanism. Try to understand what is the disadvantage of this IPC mechanism. Answer is only related processes can communicate. Will you agree? The disadvantage of this IPC mechanism is only related processes can communicate. Unrelated cannot communicate. Only parent and child can communicate. Unrelated cannot communicate. Will you agree? If unrelated processes wants to communicate, they need to take one more IPC mechanism that is called FIFO, or also called as named pipe. If unrelated processes wants to communicate with each other, they need to take the help of FIFO. Or B8F1 is asking one question, sir, if we close a file descriptor, can we able to open again? Answer is no, you can't. If you close a file descriptor, in this particular case, you cannot open again. Is it B8F1? Is that point is clear? Okay. Now observe one more IPC mechanism that is called FIFO are also called as a named pipe. One more IPC mechanism that is called FIFO, also called as a named pipe. The functions involved in this IPC mechanism, all of you copy. The functions involved in this IPC mechanism is MK FIFO or MK node. MK FIFO or MK node. After that, open, read, write. Again, the functions involved in this IPC mechanism is MK FIFO or MK node. The functions involved in this IPC mechanism is MK FIFO or MK node. After that, open, read, write system calls. All of you copied this, MK FIFO or MK node. And after that, open, read, write. What is the advantage of this IPC mechanism? Can you tell me what is the advantage of this IPC mechanism? What is the advantage of this IPC mechanism? Advantage is related as well as unrelated processes can communicate. Advantage is related as well as unrelated processes can communicate. If you are getting the point, type 2 in the chat box. If you are getting the point, related as well as unrelated processes can communicate. If you are getting the point, type 2 in the chat box. Okay. So the functions involved in this IPC mechanism is MK FIFO or MK node. Open, read, write. So first we need to discuss some theoretical concept. After that we need to go for programs. First we need to discuss some theoretical concept about this. After that we need to go for the program. All of you noted down this man page. Man 7. Man 7. Man 7. FIFO. Man 7. Man page 7. FIFO. Man 7. FIFO. Observe, FIFO is nothing but first in, first out special file. FIFO file are also named pipe. FIFO or named pipe. Observe here. All of you read this point. A FIFO special file is similar to pipe, means whatever we are discussing now is similar to whatever we discussed now. Again, whatever we are discussing now is similar to whatever we discussed now. A FIFO special file is similar to pipe, except that it is accessed as a part of the file system. Part of the file system. What is the meaning of this? Try to observe it. Till now, just now, whatever the IPC we discussed, in a pipe, there is no involvement of hard disk. Just now, whatever we discussed from the last session until now, In this IPC mechanism, there is no involvement of hard disk. There is no involvement of hard disk. But today, just now, whatever we are discussing in that, hard disk involvement will be there. Now whatever we are discussing, hard disk involvement will be there. Means some file is created in the hard disk. But just now whatever we discussed, there is no file is created in the hard disk. Now whatever we are going to discuss in a hard disk, one file is created. I don't know you remembered or not. Regular file, directory file, link file, character special file, pipe file. If you remember, in 7 different types of file, pipe file will be there. Please try to respond it. In 7 different types of files, pipe file will be there. So whatever we are discussing now, there is a hard disk involvement will be there. That's what this point. A FIFO special file is also called as a named pipe, is similar to pipe except that it is accessed as a part of the file system. Hard disk. It can be opened with multiple processes for reading and writing. Means multiple processes can open using the open system call. They can read and they can write it. When processes are exchanging the data via FIFO, the kernel passes all the data internally without writing it to the file system. This is very important point. When processes are writing the data into the FIFO, the kernel passes all the data internally without writing it to the file system. What is the meaning of this? Just give me 1 minute of time to understand this. When processes are exchanging the data via FIFO, the kernel passes all the data internally without writing it to the file system. Meaning is, just a minute. Now tell me, when 2 processes are communicating via pipe, is there any hard disk involvement? Is there any hard disk involvement? Answer is no. Now tell me, if 2 processes are communicating via regular file, when 2 processes are communicating via regular file, can I say the data is written into the file or not? Suppose one process is writing the data into the data file, hello world, and another process is reading from the file. Can I say there the data is stored into the hard disk or not? When 2 processes are communicating with a regular file, data is going to be stored into the hard disk or not? Please reply it. Answer is yes. Regular file, like using the open system call, I opened the data file, I written hello world into the screen, into the file. Another process opened the data file and reading from the file. So definitely hard disk involvement will be there. But definitely the data written into the file, regular file. But if two processes are communicating with named pipe, file is created. But observe here, when processes are exchanging the data via FIFO, the kernel passes all the data internally without writing into the file system. File system means the kernel passes all the data internally without writing it to the file system. File system means, can I say, hard disk. Again, try to observe. When two processes are exchanging the data via pipe, whatever we discussed till now, there is no hard disk involvement. There is no hard disk involvement. When two processes are communicating with a regular file, file is created in the hard disk as well as the data is stored into the hard disk. File is created in the hard disk as well as the data is stored into the hard disk. Again, when two processes are exchanging the data via regular file, the file is created in the hard disk as well as data is stored into the hard disk. But when two processes are communicating via FIFO, in a hard disk, file is created or not? When two processes are communicating via FIFO, in a hard disk, file is created or not? Answer is yes, it is created. But the data is not stored here. Everything is in a kernel space only. One more buffer is created, via that only it is. File is created, but the file is empty. File is going to be created, but the file is empty. File is going to be created, but the file is empty. File is going to be created, but the file is empty. Now you may get a doubt, sir, why, if the file is empty, why the file is created? Again, okay, good. In a FIFO, file is created in a hard disk. But what is the statement is, when any process is writing the data from the FIFO, the data is not written in the hard disk. Written internally, passes all the data internally without writing to the hard disk. So then what is the use of the file here? This file is used only for opening purpose, reference purpose, only for reference purpose. Again, this file is opened only for reference purpose, so that multiple processes can open it using the open system call. Then they can start transactions. They can start exchanging the data. But nothing is going to be stored into the hard disk. So how to create a pipe file? How to create a pipe named pipe using FIFO. There are two ways, MK FIFO or MK node. Are you getting the point? How to create a pipe file means using the MK FIFO or using the MK node. I'll show you. What I will do now. MK already I created, I think. CD FIFO. ln double dot slash header dot h dot slash. Observe the command. All of you are observing the command. mkfifo f1. Now can you tell me what is the type of header.h? Which file this is? Can you tell me what is the header.h file type? What is the header.h file type? Regular file. What is the file type of F1 file? What is the file type of F1 file? P means what is the file type of F1 file? P means pipe file. Yes, P means pipe file. One thing I need to tell you, mkfifo, mknode, these two are commands as well as functions also. Again, mkfifo and mknode, these two are commands as well as functions also. Can you tell me how to create a directory? Can you tell me how to create a directory using mkdir? What is that mkdir? Till now we used. What is that mkdir? Is a command, right? Observe, man mkdir. Man mkdir. Just give me 1 minute. What is the meaning of one here? Man mkdir. What is the meaning of one there? Can I say it is a command? Observe, man to mkdir. Man to mkdir. What is the meaning of 2 here? What is the meaning of 2 here? Can I say it is a system call? Can I say it is a system call? Will you agree? Will you agree? It is a system call. Similarly, just a minute. Similarly, there are 2 ways you can create a pipe file, FIFO file. One is using the commands, another one is using the functions. Again, one is using the commands and another one is using the functions. One is using the commands and another one is using the functions. What are the commands? mkfifo, mknode. What are the commands? The commands are mkfifo and mknode. What are the system calls? What are the system calls? mkfifo. What are the functions? mkfifo, mknode. Again, there are 2 commands. If you want, you can create it. The commands is mkfifo and mknode. There are 2 functions. If you want to create it, mkfifo and mknode. Is it clear? Now can you tell me, when you create a FIFO file, where it is created? When you create a FIFO file, where it is created? In a hard disk or in a RAM? In a hard disk. But is there anything is going to be stored in the hard disk when the processes are transacting? When the processes are doing transaction, is there any data is going to be stored into that? No. No. Now I'm going to show you. I'm going to create one scenario. This is one process, P1 process. This is the P2 process, 2 independent processes. This process is going to scan hello world from the keyboard writing into this FIFO file, and this process is going to read and printing on the screen. This is the scenario I'm going to show you now. P1 process is going to P1 process is going to scan hello world from the user. P1 process is going to scan hello world from the user and putting into the pipe, whereas P2 process reads that hello world from the pipe. P2 process reads that hello world from the pipe. No need to synchronize. Read will block when the pipe is full. Write will block when the pipe is. Read will block when the pipe is empty. Write will block when the pipe is full. No need to synchronize. B8 F1. We'll see that. I'll show you. Now this better I'll write a program instead of copy and paste. Header.h void main mkfifo. What is the F1? 0664. Error. I'm creating the FIFO file using mkfifo. Again, I'm creating the FIFO file using mkfifo. After that, fd is equals to open system call f1 o underscore wr only. After that, p error open. Otherwise, I'll put if fd is less than 0, then the p error, no need to further proceed it. Return. Otherwise, printf enter the data. Scanf percentile s comma s write fd s strlen of s plus 1. strlen of s plus 1. What is the job of this process? Job of this process is to scan data from user and put it into FIFO. The job of this process is this. Another process, a reading process. This is a writing process, right? strlen of s plus 1. Am I did anything wrong? Just give me 1 minute. strlen of s plus 1. So I'm putting /0 also into that. Okay. strlen of s plus 1. I'm putting /0 into that. Okay. So CC 2709, just a minute. 2709 hyphen O W1. FD is undeclared. Writing process is ready. CP 2709 underscore 2 2709 underscore 3 dot C 3 dot C. Now this process is for what purpose? The job of this process is to read data from FIFO and put it into screen. So I need to open for RD only. Now here I need to open for RD only. Read system call FD S size of S CC hyphen O RD. Now will you agree? WR process or RD process both are present. Writing process and reading process both are present. Let me show you it will work it in this environment or not. So this is which process? Reading process. Just a minute. I'll open one more terminal. CD Linux underscore 89 file management IPC FIFO. So there are two processes. One is a reading process, one is a writing process. So /RD. Can I say reading process is waiting, and /WR W1 HELLO. Now tell me, when writing process writes the data, reading process got the data or not? When writing process writes the data into the FIFO, reading process got the data or not? Two independent processes. These are not parent and child. These are not parent and child. These two are independent processes. These two are independent processes. These two are not parent and child. So tomorrow many more things we need to discuss about this FIFO. Full duplex communication, half duplex communication, simplex communication. And the functions also we need to discuss. Suppose if write will write first. Good question here. I'll show you that. Suppose here if I write A B C D E F G H, okay, then if you read it, See, again, try to understand here. Suppose when writing process writes it, then reading process afterwards it comes. It will read. We'll see that tomorrow in detail. We'll discuss it. Don't worry. What happens inside? What is the things are happening? We'll see that. Is it clear? BE8 F1 tomorrow we'll discuss in detail. Okay, thank you very much. And one more thing is your communication assessment is scheduled, and I think SMSs also you received it. Please attend the assessment, communication assessment. Thank you very much. I'm going to wind up the today's session.